Hi, this is Margo. This is Monday afternoon, February the 3rd, 2020, and this is going to be my weekly methane and climate update for my YouTube channel, and I hope everyone is doing as well as possible. I'm not feeling great, but just reacting to different allergies and stuff, but I did the show on Wednesday where I did a methane update and talked about some other things and posted that on YouTube. Now, I was kind of waiting to do until we got more recent methane data from CAMS, but the only methane data we have now is from Thursday, January 30th, which was the day after I did the last show. So we'll go ahead and show that, and I've got my NOAA readings for last Saturday. We can look at that. We're going to go over a comment discussion that I had with one of my viewers on YouTube about a weird thing near the Antarctic that we're not sure if it's methane coming up or not. And then we're going to go over Climate Reanalyzer, and we might take a peek at NASA Worldview just to see what the sea ice is doing. So that's the plan. So here we go. So this is from Thursday, January 30th. We have the Arctic view pulled up and surface level. And this is from Copernicus Atmosphere Monitoring Services out of the EU. And this is the only day they have up. And their model down here it will use the day of the data, and then it forecasts forward for 4 days. So once this runs out, there won't be any methane data until they start putting it up again. So I don't know why they're getting behind. There's just no way to know. But this is just typical. So here's the chart down below. And I already have the movie loaded up. So this is where it left off on Wednesday with this huge release in the Arctic, and we can see this is a huge release into the very high levels of the dark brown, which can be anywhere from 2160 to 10,000 parts per billion there. And this is still in the dark, this area, and it's coming up through the sea ice. And this is Severnaia Zemlya here. And we're also seeing high releases to the west of that, and then here in the Kara Sea. And we're still seeing high releases on the northern coast of Alaska. And we're seeing higher releases come back in Russia. So let's run this and see what all we can see today. We're also seeing some yellows being released here in the Chukchi Sea. Now notice how it plays out. And then, it releases on Thursday, and then into the forecast period, the wave kind of moves out and it plays out. And then at the end of the forecast period, it's got a new part coming up. So it's kind of pulsating, which is typical of how we see these methane releases come. We've got some high releases here in Siberia and down here. But look at this. On this north coast of Alaska, I'm just thinking that's oil drilling. That's what I'm thinking. From oil wells, that area. So now let's look at the North Pole view so that we can see the northern hemisphere. So looking over here at India and China and Asia, it still has very high releases. We're still seeing some white spots pop up in China, and I deduced that's the methane is higher than what's on their chart, since it's white instead of brown, which would be above 10,000. Unless somebody knows better, that's kind of what my theory is going to be. And we've got high releases here in the Persian Gulf, super high releases. Let's look at East Asia. If we look at Eastern Asia, we can get a close-up view. So here's China, and then here's India, and so we can see it's going to take a minute to load this up. Let's see if there are any white spots popping up. Yeah, it looks like little popcorn. And then down here, now remember, Wuhan is down here in this area. I also saw there's some areas in India that has some white coming up too. Watch, right in this, right there, see? So we've got some definite hot spots. There's one that's consistent right up here. This is kind of northern China. More near Beijing, it looks like. So now let's go to the global view. We still have this real high release up here on the Canada-US border. This is not Yellowstone. This is more to the east of Yellowstone. So it could be oil, but we're having some very high releases here in the United States, it looks like. High releases in the interior of Brazil, and just different places. Okay, so, and you can see there's that big release in the Arctic. When you get a different viewpoint, it looks a lot bigger. So now let's look at 500 HPA, which would be close to the 477 millibar reading that we look at on NOAA. So we're seeing it's mainly gathered up in these northern latitudes, but it's kind of red down here across the United States too, and down here got some higher releases over here. Here's Japan. And now let's take a peek at total column. So here it is for total column for Thursday. We're seeing very high releases over here in China and in eastern India, and also moving over the ocean here and over Africa. This is in the Congo. And then we're moving into the orange and dark orange ranges across around the world as well. You can see it. You can see it really good over the oceans. So we're going to leave that. Now here's the NOAA images. This is from Saturday, February 1st. And this is the Met-1 satellite from the morning. The mean is 1872, and the range is 1448 to 2445 parts per billion. And so that's the chartreuse color is the highest, between 2000. So that would be between 2000 and 2415 parts per billion in the chartreuse color. And so you can see that at different places. This is missing data here. Pretty much all of Greenland is missing and a lot of the Atlantic. And then the gray is no data as well. So there's the first image. Here's the Met-1 for the afternoon. The mean is 1876, and the range is 1463 to 2416. Here's the Met-2 satellite from the morning, and the mean is 1854, and the range is 1447 to 2347. Now this is lower than we've seen in a while, and we're seeing, instead of just chartreuse all the way across this northern part, we're seeing more of the darker red, and so that's probably around 1900 to 2000 parts per billion. And then here's the afternoon, and the mean is 1854, so that's lower than the morning reading, and the range is 1459 to 2312 parts per billion. Now we are seeing the chartreuse up here where we saw that release, that large release from the Severnaya Zemlya area, so that fits. And so there's that. So here's our spreadsheet that we've been looking at. So here are the numbers for this week. I took all the numbers and added them up and divided them by 4 and we come up with a mean for this level between all those numbers of 1864 parts per billion, and that's 3.5 parts per billion lower than the week before, where it was 1867.5. So we can see the line going down even more steeply here. This is in this last week. And the week before that it went down 0.75. So, but it had been going up. In January it had been going up 4.25, 0.75, 1.5, and so now so this is where it was going up in January, and it peaked out here, and now it's gone down in the last 2 weeks, but we're still 6.75 parts per billion higher than when we started measuring this March the 1st. So we'll see when we get to March the 1st if we're higher or if we're the same or lower or what, and then we'll have a year's worth of data that we've been tracking on our own here, and so we can get our own trend going. Because what it did last year, it started going up in March, and normally it doesn't start going up until around April. So we'll see what it's going to do this year. But so there's the methane. Now let's move on over to the next part of our report. So here we are on Climate Reanalyzer from today, the 3rd. These are the maximum temperatures around the planet. We can see that the Arctic is in the purple. So it's a lot of it's in the purple, but some of it is in the blue, which is getting blue is warmer, and then this aqua color, that's like 0. So this is the air temperature. So here it is worldwide. So we can see that Australia is pretty hot. We have parts of Africa that are really hot. Asia, the southern Asia, and all these islands, they're hot. Brazil, South America's hot. And you see the air, the equatorial air around the planet is definitely in the red zone. It's getting up 25 to 30 C. So it's getting on up there. If we look at the 2-meter temperature anomaly, then we have an area in the Arctic just north of Svalbard that's in the red zone. So brown is 10 degrees higher than normal. Red is 20 to 25 higher than normal. When you get up into the pink range, that's 30 degrees higher than normal. This is centigrade or Celsius. We can see a large area in Canada that's in the red zone. And then there we've got a big wide area moving from west to east across the United States that's in the dark red zone. So here's the planet. We can see a lot of Russia is in the red zone. And then Europe and European countries are in the brown zone. We've got a lot of browns over Russia and over here. A few in Africa. But in the Antarctic, a lot of it is brown. So worldwide, we're up 0.5 degrees Celsius higher than normal. Northern hemisphere is up 0.8 degrees. Southern hemisphere is up 0.2. The Arctic is down 1.2. The Antarctic is up 1 degree. And the tropics are up 0.4. So even though we've got this red area here, that didn't offset the colder areas in the Arctic. But this northern hemisphere, 0.8 degrees, this is including all these red areas over here in Russia and all these brown areas and the red and brown in North America. So there's that. Here's our precipitation. It's snowing in the Arctic, coming across from the northern tip of Norway across to Svalbard, and it's raining in southern Norway and across over to Iceland. So let's look at the world here. So this is what the rain and snow are doing. The green is rain, the blue is snow, the yellow part, that's your extreme, like your cyclones and things like that forming. That's heavy rain. And we can see that it's even raining in the Antarctic, or almost on land, which is pretty unusual. Let's click around and get a better look at that. That looks interesting. We don't normally see rain that close. Okay, so this is north, south, east, and west. Here's the western peninsula, and we can see that it's raining and snowing in this Weddell Sea, and we've got snow on this western side of Australia. Pine Island Glacier is right over here, and then it's raining just next to that snow. So, and it doesn't snow much down here. It snows some, but not very much. And then let's look at our jet stream. So we've got our split up jet stream again. Here's one, and here's another split. And look at all these splits down here, and then here's another one coming across. So it's like 3 jet streams. Hang on. 3 jet streams from the Pacific. Then it splits up, and that's crazy looking. That's not normal at all. And then it's also split in the southern hemisphere. See? It splits and goes up over Australia, and then it splits and goes south. So here we've got 3, 1, 2, 3 coming up and merging. Looks like they all merge here. Here's the fulcrum point on the northeast coast of the U.S. Major jet stream coming over Europe here, and then look how it's a straight line just zipping across from Africa all the way across there. And now let's look at the sea ice and snow cover. I'm not really doing a sea ice update today. I'll do it later on the week or sometime soon. So there it is in the Arctic. We can also see all this white area is snow. And here's the Antarctic. And now the sea surface temperature anomaly. They're day behind here. They've got Sunday's data up, but that's pretty recent. So we can see the browns up here in the Arctic around Svalbard, and then coming on down and all around Greenland. And see all the browns and reds here in the Atlantic, and then brown. So let's look at the world. So a lot of red over here around Japan and Korea. And then look at this brown in the Atlantic here. And it's brown around Australia, but especially between Australia and New Zealand. That's hot. And then all around the Antarctic, it's in the brown. So worldwide, we have the sea surface temperature is up 0.4 degrees. Northern hemisphere is up 0.5. Southern hemisphere is up 0.3. The North Atlantic is the winner. It's up 0.6. And the North Pacific is up 0.5. And Equatorial Pacific is up 0.4. So the North Pacific had been hotter consistently, but today the North Atlantic is hotter. Then the equatorial, that's all this area here where we're seeing this is the equator runs about here. Well, the zero. Where it's zero, that's the equator. So we can definitely see the browns and reds around there. So there's Climate Reanalyzer. Now I want to cover this comment that came in under my update from last week. This is from Dave R. And he says, "Hey Margo, would you mind checking offshore Antarctica for a possible huge methane plume? There's a weird anomaly on Google Maps." And then he leaves a link to this YouTube video. And when you click on that, it goes to a video from Mr. BBB33. And someone had sent in a picture from Google Earth that he was looking at. And so I took a look at it. So let's just go to Google Earth. And it's in the Antarctic. And what it is, it's a little tiny island off the coast of this western archipelago. It's up here. Wait. The landmark is this, so that's not where we're going, but the landmark that I use is this area. It's called Deception Island, and then it's over here. It's in this area, and you just keep zooming in, and it's this little point, and when you just keep zooming in and zooming in, and this is what you get. And this is what they were showing on the video. And if you go too close in, it just, you can't tell anything. So first of all, this part, it looks like a little tiny island. That looks like land. That's brown. And Mr. BBB33 was like, "I don't know what that brown thing is." Well, that looks like an island, and this white part looks like snow. Remember, that's very cold down there, and depending on the time of year that this picture was taken, you know, it would reflect things too. And I don't know how old this picture is. There's really no way to find out because this is satellite imagery, and when you go to Google Maps, it just says copyrighted 2020. But generally they're about 1 to 3 years old. So what we're looking at is this stuff here, and it balloons out. It's actually out much further. And he was saying, is this a methane plume? Well, You know, I don't really know. It looks like some kind of anomaly. It looks like methane to me. It's got the color of methane, that blue-green, but it would be huge, and I'm thinking it would have to be kind of an ongoing thing, or it was it wasn't just a burst and it went away and they happened to catch it on the satellite. But there are volcanoes, active volcanoes down there under the water and under the ocean. I'm thinking it could be a volcano that is not talked about. Or it could be a methane vent, or who knows what. But it's really tiny, and it's in this black area, which I don't know why that area is in black. But it's a little itty bitty tiny, and how that viewer found that is amazing. But what they do with these satellite images, see, they've taken away all the clouds, and they kind of do a composite for the sea ice and stuff. And these are Larsen ice sheets, ice shelves here. And so it's hard to tell when that was or what it is even. See, here's the ice. Here's some ice sheet. So was this taken in the summertime? Did they kind of like take the ice away? Because we are seeing all the coastline here. So I don't know. It's interesting though. And so the way to find it, you go to Google Earth and you come to this tippy point, and then you go up. There's this ridge of islands here. And then you find this horseshoe shaped Deception Island is what that's called, and then you go to the left to this dark area, and then that little white spot, and you just keep zooming in. So if anybody wants to go take a peek at this and let us know what you think it is in the comments, that would be great. I don't know if this is ice that had melted. I kind of doubt it. I think it's more like a plume of something coming up from under the water. That's my theory. So thanks for that, Dave R. And anyway, this we talked about. I talked about the discussion there, and Dave R. finally responded. The last thing in the thread says, "I think this answers that question." And it's an article from EcoWatch. It says record warm water measured beneath Antarctica's Doomsday Glacier. Now this is referring to the Thwaites Glacier, which is not near there. Not near where we were looking. And this is from January 30th, 2020. But the warm water is because the volcanoes are going off. They have hundreds of volcanoes underneath there. Like, they keep finding new ones. So where's the pictures? It's this whole long article. What the researchers did and this and that. The Thwaites Glacier has been called the Doomsday Glacier and the most important glacier in the world. The glacier, roughly the size of Britain or Florida, already contributes 4% a year to global sea level rise. Not only that, it acts as a stop on the rest of the West Antarctic ice sheet, which could raise sea levels by more than 3 meters, approximately 10 feet. You know, it's not the only glacier down there, you know. So, it could be that, you know, what we're seeing on Google Earth is the warm water. I think it's a volcano coming up. That's what I think. So, let's just take a peek. Here is NASA Worldview from today. Here's the Arctic, and the black is where it's still dark, but the Earth is tilting. The northern hemisphere, northern part, is now tilting more towards the sun. It's beginning that, and the southern part is moving away from the sun. So we're starting to get some areas. Iceland, here's Iceland. It's completely in the sun now. And we're seeing more of Greenland here. Here's the ice on this edge of right edge, the eastern edge. And here's the ice in the Baffin Bay. Right there. We can see it doesn't come up to the coastline. These are clouds. But the ice is over here. Then we can see, so this looks like, I can't tell if that's clouds or ice. Here's Norway. That must be clouds. Here's the Kola Peninsula, Russia. Here's Novaya Zemlya. It's almost in the sun. And so we can zoom in here. Here's the sea ice. It's really broken up. We're looking through some clouds, but it's not very well formed at all. It didn't form very well around this area at all. There we can see that's the sea ice. Here's the Yama Peninsula coming out. No, here's the Yamal. I got disoriented. Here's some more. Here's the sea ice next to the Yamal Peninsula. That'll melt really fast. And they have icebreakers that go around through these areas. It looks like this is where an icebreaker has been. I mean, just because it's winter and dark up there, they don't stop doing stuff. That's in the clouds. So that's all dark. So here's the Kara Sea, here's the Laptev Sea, here's the Chukchi Sea. This coastline is starting to come into view, but we're seeing clouds. We can't really see any of the ice there. Here's the Bering Strait. Here's Alaska. We have got a lot of clouds here. Right up here is where all that methane was coming up. That's still in the dark. This area. Here's Barrow. So once that comes into the light, we'll be looking at that. Here's the western edge of the Beaufort Sea, Mackenzie Bay. So we can see the lines in the ice there. Here's an, and that's, we can't really see anything there. So that's what the Arctic looks like right now. So we'll be watching this as it comes into view. It will be interesting. Here's some sea ice in this area. See? That's pretty broken up. Now let's take a peek at the Antarctic. And down here, this is the Western Peninsula. And look at those clouds. That does not look normal to me. So where we were looking, Deception Island, it's hard to find through all the clouds, but it was over here. So here is the iceberg we've been watching, the A68 iceberg. It has gone further out and turned and rotated. It's almost horizontal now, and it looks like it's going to go out to sea. See if we can get a better picture of it. Look at those waves. Okay, you can see it through the clouds here. This tippy point is more like an 11 o'clock position. And now that was from the 24th. And now watch here and here, and you'll start seeing it shift. There it goes. It's moving. There's the 31st. You can see it's almost at a 9 o'clock position. There's the 1st, 2nd, and here it is today. So that's just amazing. And that had broken off down here on this Larsen Sea. It had broken off down here a couple of years ago. Here's Pine Island Glacier. We've been watching that. Now we're looking at clouds here. Here it is yesterday. We can get a pretty good view. Got some clouds. It's still got the lines. It's going to break off. It's going to calve. Here we can see. That's a good picture. See these lines? It's breaking off. And the Thwaites Glacier is down here, right in this area. That's the one they were talking about in that article. Here's the Ross Ice Shelf and the Ross Sea, and today we can see that all of the sea ice has broken away completely and melted. These are clouds. And then this is the ice shelf. This is Ross Island. And right here is Mount Erebus, the volcano that's constantly going off. McMurdo Station that you hear about, the research station, it's over here. And then we're also watching this piece that had broken off, this D28 that had broken off of the Amory ice sheet. See, it's so cloudy you can't really see it. Here it is. Here's from the 29th. It looks like we had a breakup. Look at all of these pieces, these chunks. That looks like a breakup. This is A28 right here, and it had broken off down here in October. And we've got some more ripples there that you can see in the clouds. But it looks like this had been kind of lodged in the sea ice. It looks like there was a breakup. And it looks like that D28 is going to be able to move on out now. There you can see the edge of it through the clouds. That was yesterday, and here it is today. It looks like it's right there. So that's it. So I'm going to go ahead and sign off for today. And I do believe we are in the end times. And no one knows the day or the hour, but we need to be prepared. And there are huge changes. We're in the midst of huge changes of all different kinds. And I recommend that you get your spiritual house in order so you don't have to worry about that. And if you haven't done so already, get right with God and Jesus. And I'd like to thank Dave R. for leaving that comment and for us to, something interesting for us to look at, that is possibly methane coming up. So until next time, God bless you, go in peace, and I'll talk to you real soon.